Okay, so we want to take all of that data that we collected yesterday and figure out what it meant and what the purpose was going through all of that, moving around and collecting data. Okay, so the first thing that you did for homework was you plotted all of your dots. And the first experiment that we had was a completely randomized design. So I want you to really kind of know what that means. A completely randomized design means that we took all the dogs and then did what with them? Yes, we shook them up and then randomly assigned them to the treatment groups. So with completely randomized, there's no block, no special grouping. We just randomly assign them to the treatment groups. Okay. So we didn't attempt to make any control over the breed or the clinic or whatever. All right, so let's take a look at our questions down below. Can you see, let's go ahead and discuss first off. These numbers to the left, what do you think those numbers as the scale goes to the left mean?
You're losing more bone density.
Good. So this is more bone density loss. So I want you to kind of understand what's happening in context. And then, of course, as you go to the right, that means what? Less bone density loss. Okay? And then the dots are the pieces of data that we had yesterday and the results that they had. Okay, so can you tell a clear difference in the results? Difference in where this centrally located for the 3 different treatments? I mean, I agree. I don't think it's a huge difference if it is one. Yeah, there's not a, they're really both kind of spread out quite far, They're all kind of spread out, and they're pretty much located in the same vicinity. Okay, not a clear difference. So we're going to say no. There's not a clear difference of which treatment is creating less bone density. For example, you may say, well, it looks like the controls shifted a little bit left. But let's talk about this. Look at these 3 guys. These 3 guys are way lower than these 3 guys, So you can't see a clear difference. All right. Now, when we go here, we're going to now talk about the variability. And so let's talk about what that means. This variability, it's talking about how spread out the data is. How spread out the data is. Because it is good, by the way, it is good to have consistent data. How would consistent data look? Good. Closely clustered together. And do you remember whenever we did our random rectangle activity? We kind of talked about that. And we had the strata ones, and all of our numbers kind of were in the same area. So we talked about that variability. Okay, so closely clustered together as opposed to being really far spread out. Okay. So are we able to see much difference in the variability of the 3 groups? How much they're spread out? They look about equal spread out as well. I don't see much benefit. In fact, I went and figured out what the range was. And so here's how I did that. Because I was curious and, I didn't want to subtract on the spot because that's bad for my brain and inaccurate for me usually. So I took the highest value. So I took this highest value and I subtracted this lower value. So, for example, in the top case, the highest value was this -70, and I subtracted away this -138 to see that the range was 68 points. Okay? So these numbers were in the high 60s and in the 70s. So that was the range. So they're quite spread out. Because as we go into other treatments, you might see difference. Okay, so because all the data is very spread out, we do not see a difference in the treatment benefits. So that's another reason why I can't tell if there is a treatment particularly better than the other. Because all data is very spread out, we do not see a difference in the treatment benefits of the 3 treatments. Okay, so then we went to experiment number 2. Experiment number 2, what did we do with that? We blocked by breed. Okay, so let's talk about the purpose of that. Why do we block? Why would we block by breed?
Some of the dogs
breeding
are
was
smaller than the other.
average benefits.
So like,
If they
the smaller dog rears less.
Okay, so we say block by breed. Remember, this is the bubba of our Babratmi cap. We blocked by breed because we think the breed affects the bone density loss. Yes, and yeah, just make sure you don't say it affects the response, or it affects the outcome, or it affects the, what's another? Result. Yes, those 3 generic words are bad. We want to be specific about exactly what it's affecting. Bone density loss. Okay, so we blocked by breed because we think it is affecting the bone density loss. So looky here at our data in this situation. We subtracted out that variability due to breed. So is there a clear difference in the treatments here? I mean, other than a little overlap right here, yes. You can definitely see a difference between where the centers are located. So I want you to now think of teeter-totter, and let's kind of see if we can't locate the center of these things. So think of kind of like where the fulcrum would be and where the average is. So if you had to picture a teeter-totter or a seesaw, where would you put the center? I'd actually probably put it somewhere about right here in this area. Probably, would that give me about equal weight on either side? Can you visualize that? They're closer together. There's more of them closer together, but this guy that's far out here to the left, he's kind of applying more particular force, and I don't know exactly what the technical physics names are. Okay, so yeah, and then how about our center for the calcium treatment? Where would you probably put that? Yeah, that one's actually probably pretty close to being right there. Okay, and so I thought that was supposed to do that. Okay, cool. And then how about the control group? That center's probably going to be, I'd say probably somewhere about in that, you think a little to the right. So somewhere along those lines, somewhere 6 to 7, somewhere in this section. Okay, so yes, we can see a clear difference. Can you estimate those average amounts? And so let's put those down. So for the, what was it? For the EX group, it's around, where did we say that it was around? The center was around 5 to 6. I think the EX group was positive.
Oh, yeah.
Okay, and the calcium had a center located around 1 to 2. Okay, around 1 to 2. And the control group had a center around the negative 6 to 7. Okay, so yeah, they are definitely centered, okay? What do you also notice besides the center? What can you tell me about the spread of this page? Yeah, they're more closely clustered together. Do you see them being more consistent and more closely clustered together? Furthermore, you can't even see it. The scale on this was changed. Did you notice that scale at the bottom was changed? So let me tell you what the ranges are on these. While the range on the first experiment were in the 70s, look at the range for these. in the teens. So that is huge. That is huge. Breed had a huge effect on the variability, on the variation, on the how closely clustered those were done. If these were put on the same scale as the first experiment, they would be so very much crunched together in the middle. Okay, let's go to the third experiment we did. And that one we did what? How did we organize it? We blocked by clinic. Okay? While I got this showing, let's look at the variability of those. Here are the ranges of that data. Look what we're back to in the 70s, and then one in the 80s even. So our variability is back to being very big, and apparently that's because blocking or clinic did not affect our bone density loss as much as breed did. Okay, so is there a clear difference in these treatments? Not really. Look at them. The centers are, they're chunked pretty close together. So, in summary, which simulation, completely randomized, blocked by breed, or blocked by clinic, was it easiest to discern the effects of the three treatments? Definitely blocked by breed. Definitely blocked by breed. Okay, so we're going to write that down here. And then, sometime whenever I wrote this paper, I wrote this little question here, and I'm thinking in hindsight, what the heck was I going for there? I don't know, so let me think about it. How did the characteristics of the variables and the particular design, okay, work together? I don't know what I was going for there. The only thing I can think of in hindsight that I wanted to stress is that with the blocking by breed, you could see a clear center. You could see a clear center. And the main thing is that the variability was greatly what? Reduced. Very good. The variability was greatly reduced. And that is a key idea that you need to know about blocking. In fact, we're going to summarize right now the key ideas that you need to know about blocking, and then we're going to listen to the song that has to do with those key components. So, you don't have to write these down, but I'm going to go ahead and write down that. Here is blocking. Let's see. When would we choose to block? If we think there is a what? Perfect. If there is a trait that affects the way subjects respond. Okay? To the treatment, what we're measuring. So if there's a trait that we think affects the way subjects respond, then we consider blocking. Okay. And so when you block, when we took the dogs and we put them into Akitas and Collies and Beagles and Dalmatians, what's the quality of the blocks? What kind of groups are they? By breed. And so they are similar groups. So we make homogeneous groups. Okay? So blocking is making homogeneous groups, just like when we did sampling, strata was also homogeneous groups. Same thing. Okay. And this blocking dogs lab, what was the key difference that we saw with the second experiment as compared to the first and third experiment? What was the key? Consistency. We significantly reduced variability. It had consistency. We reduced that variability. Okay, and then also I wanted to just remind you that, do you remember when we did a blocking experiment and we wrote it out? We said something like, in the overweight block, randomly assign this and do this experiment. So we said, within the overweight block, wrap me cap Okay, and then after we described the experiment in the overweight block, what did we do then?
Repeat it with the.
Perfect. We said repeat within the average weight block or whatever. So we repeated within each block. And so that's the final thing. Within each block, you have that same experimentation. So these are the key phrases in summary that I want you to know about blocking. And so here we go. Let's see what I can, oh, look at here. Grr. Can I grab that? I do not think I can grab this song. Almost. Almost. It went away. Okay. Well, we'll just try this another way. And my